So we're going to see if we can fix stick drift using some adjustable resistors, also known as potentiometers. Let's look at this board here because it's pretty easy to see what's going on here. You've got your analog stick here, and it's adjusting these potentiometers here. We'll flip it over, we can see that there are 3 pins. The pin in the middle is the sensor pin, and the side pins are ground and positive voltage. So what we want to do is figure out if the middle pin is biased towards ground or positive, and then use a variable resistor to pull it in the proper direction. Now, it's been suggested that this only works properly if you have 2 variable resistors, one connected to ground and one connected to positive voltage. So that's the setup that we have here. These are currently not connected though, so we can see how the device is working before we do anything to it. Here it is. It's a stick that we're moving here. Because of earlier experiments, we don't have both axes, so it's stuck up on the top, but what we're interested in is the left-right motion. And you can see that this stick does have some amount of bias, somewhere around plus 15% on average. Okay, so now we're going to connect up our variable resistors, and here you can see how it's set up. The wires underneath the controller are going to this trio of pins that you see on this board here, and they come out. The center pin goes to this set of alligator cables, and each of these alligator cables are going to go to our potentiometers, and those potentiometers are connected to the ground and positive here. So the idea is when we move either of these potentiometers, we can inject a bias current into the middle wire of the potentiometer in the joystick, and that's the pin that is being read off to determine where the joystick is. So now we should be able to adjust things. So let's go ahead and connect things, and you can see that the overall effect is better. Now that's at maximum resistance. If we reduce the resistance, we inject more current, and we can see that the neutral point is shifted. So it's pretty easy to find a point now where we have a perfectly unbiased, non-drifting analog stick. And here's the configuration that we've got here. We've got the one that's pushing us in the wrong direction at 43K, and the one that's pushing us in the right direction at 22K. Now, the reason why I have this one that's not really doing any good here in the circuit is because of the claim that that's what's necessary in order to get the stick to perform properly inside the Xbox controller. So let's see what happens when I move the stick now. Is it going to work properly over the whole range? And the answer is no. You see how it's sort of jumping there? So that's not me. That's that jumping behavior. I'll just gently push it all the way towards the maximum range, and you'll see it goes back and forth, back and forth. That only happens when you have the potentiometers in the circuit. And it happens whether you have one potentiometer, just this one, or 2. Interestingly, it only happens in one particular direction. So if you go in the other direction, it's fine. If you go in this direction, the direction that we had to correct the bias away from, you see that bounciness. See how it has a really big jump right there? That's not a mechanical thing. That's not noisy pots. That's something about how the readout circuit in the Xbox controller works. So to conclude, it doesn't seem like it's really possible to use a setup like this either in a nice large, not very portable configuration, or in a nice surface mounted component design like we've seen in the other video that this is going to point to adjust these Xbox controllers. For some reason, the readout circuit doesn't work. Now let's go ahead and take out the one that's not helping us any. So this one here, I'm just going to disconnect, and you can watch what it does. And you can see it actually pushes us further over towards that direction. We're going to pull it back. Okay, so now we're injecting less current into the system, and we'll ask the question, will it work better now when I slide this thing? We'll try and make it so you can actually sort of see what I'm doing here. I don't know how visible this will be. Okay, and you can see it's pretty bouncy. Now it's a little hard to control this thing smoothly, so I invented this tool, to give myself a more gentle control of the joystick. So here I am moving it very smoothly, and you can see it's bouncing back and forth. And then it makes a big leap right at the end. And now I'm going to come back gently, not doing anything, and pow. So, unfortunately, adding this resistor into the system is not leading to a very good performance on the part of this Xbox controller. This controller in particular, it's a genuine Xbox One controller 1537. I've done this same mod using a Power A controller, renowned for their low quality. Interestingly enough, there it works fine. So I think that it's something special about the circuitry in here. And it's kind of mysterious what exactly the circuitry might be doing. Something non-intuitive. But it's unfortunate because this idea of using a resistor to fix stick drift or joystick bias is a great one. It's by far the most elegant solution to the problem, if it worked.